Hello, everyone. Welcome back. Today we are going to be talking about scalar multiplication of vectors. So here's the thing. Let's say we have this vector u, and I want to draw 3u. Well, that would just look like this. 1, 2, 3, right? We did the same thing 3 times. Now what about minus 2u? Oh, well, let's go back to 1, 2 backwards, right? The opposite direction, same magnitude, right? So basically for any vector u and scalar k, the vector ku is a vector that is the magnitude of k times longer or shorter as u. So you can see here, this one is 3 times as long as our original vector, right? This one is 2 times as long as our original vector, just in the opposite direction. So basically we take the absolute value of whatever number we're scaling it by, and that's how many times we multiply by to figure out the new vector. So if it's in the same direction, then k would be greater than 0, right? If k is a positive number, or I'm going to put in brackets positive, then that means that it's going to go the same direction, right? If it is the opposite direction, it'll be less than 0 or a negative number, right? We had the -2 vector. We went in the opposite direction because that negative indicated to me that it was the opposite of whatever the original vector was telling us. And then if 0 is k, then that means we have 0, right? We're just going to go nowhere if k is 0. If it's 0 of the u vector, we're not going to do this any times. That means we're out of luck and we're just going to stay put. So ku and vector u are said to be parallel or collinear, right? Translating the vectors may put them on the same line, right? So if the vectors basically, if they're the same magnitude, or sorry, if they're the same direction, then they're collinear, right? Collinear is typically what we call them when they are parallel or same direction, but we usually in vectors will use the word collinear. Okay, so keep in mind the magnitude isn't going to be the same for u and ku, right? It's ku is going to be longer or shorter depending on what k is, right? However, they will always be parallel lines or same direction lines or collinear in these cases. Okay, so let's do an example. Given this chart, express terms of vector A and or vector B. Okay, so let's go ahead and do that. So let's say that this vector, I'm just going to make it up now. The two main vectors we're probably going to need is that vector A, let's say it's this one, and then let's say that vector B is that one. Okay? All right. So let's look at what is AB, right? All the way from this point here to this point over here. Well, it looks like we have to do vector B twice, right? We have to do vector B twice. So I'm going to say this is 2 of vector B, right? Okay, what about DA? Okay, so let's start here from D all the way to A. Well, it looks like we're going to be using vector A, and we're going to have to use it twice, but also in the opposite direction. We're going to go from here to here, and then from here to there. So we're going to end up doing -2 vector A. Now, what about X, Y? XY should be labeled. My apologies. X and Y are supposed to be these ones. So that would be B minus A, right? If we start at X, we have to go, or sorry, A should be A minus B actually, right? Because we're going to start here. We're going to go and take A the opposite direction, right? And then we're going to just go right to B. What about YC? Well, we would have to go here and do the B vector, first of all. And then we would have to do 2 A vectors. We have to get up here, up halfway, and then up another halfway to get to the full way. So plus 2 of the A vector. Now what about xc, right? How do we get from x to c? Well, we're going to go up 1 like this, so that's going to be the A vector, plus, let's see, 2 B vectors. We have to get halfway and then full way in this direction, so plus 2 of our B vector. And what about the last one, from B to D? Okay, so B is here, and D is over here. Well, we could do 2A and then minus 2B. We're going this direction twice, right? So that's going to be our answer, 2A minus 2B, like that. I'm just going to get rid of all these extra lines here, but I am going to keep my vectors and points labeled on there. But there we go. It's the basic idea, and it's very similar to what we were doing before in the other lessons. The only difference here is that now we're adding in the scalar multiples. So we're sometimes, using the same vector more than once, whereas before we were just using each vector once or no times at all. Awesome. Okay. So let's do a couple of more examples. Let's do 2 more examples of this. Here it says vectors x and vector y are unit vectors. So what are unit vectors? I need to introduce those for those who maybe are unfamiliar with the concept. A unit vector means the vector has a magnitude of 1. So basically whatever vector we have, we can always figure out what the equivalent unit vector would be if we were to change it down a little bit, right? So x and y are being unit vectors means our magnitude is 1, and they make a 40-degree angle with one another. Calculate the value of 2x plus y and the direction of 2x plus y. So what do we know? Well, we know that x and y are unit vectors, so their magnitudes must each be 1, which also means their magnitudes are the same, by the way, too, which is actually even more useful than the actual number they are themselves. So keep that in mind. Unit vectors, 2 things being unit vectors, also means they're the same, right? Or the same magnitude, I should say. Let's say this is vector y and this is vector x, and they have a 40-degree angle between them. Okay, so we would like to know, if we did 2x plus y, what would the resultant vector be? So I'm going to do x again here. Let's draw it again. And then y like this. Now, again, something I mentioned before in the previous lesson is that, remember about our how our parallelograms work, right? If this is 40 degrees, we have to add something to that to get 180 for the full line. So therefore, this would have to be 140 degrees. Okay, and that's key. That's going to be good, useful information. And I would like to know, what is the resultant vector, right? If I do that, what is this vector 2x plus y going to give me? So let's do it. Okay, so let's see. So a squared, which is going to be our 2x plus y squared, is equal to b squared plus c squared minus 2bc cosine of a. Now, in this specific situation, we would like to find the 2x plus y. We want to find that magnitude specifically. So I'm going to say, therefore, a squared must be 2 squared plus 1 squared. Why? Right? Because each of these are 1. So total, this is 2, right? If these are each equal to 1. And this one's also equal to 1, right? So 2 and 1, based on the fact that they're unit vectors and have magnitudes of 1 each, minus 2 times 2 times 1 times cosine of 140 degrees. Therefore, a squared is going to be equal to 5 plus, 3.064, which means a, if we take the square root of both sides, we're going to get 2.84, because this is going to be 8.064. Okay, so there we have it. We know, therefore, that is the magnitude. Now, what about the direction? How can we find the direction here? Well, I would like to know, what is this value here, this theta? And how can I do that? Well, now we have a side angle pairing, so we can use the sine law to figure that out. I can say that sine of theta over 1 must be equal to sine 140 degrees over 2.84. And therefore, sine theta is equal to sine 140 over 2.84. And therefore, theta is equal to 13.08. So therefore, what's our answer? Our answer is that 2x plus y, that vector here, the resultant, is 2.84 centimeters. And our direction would be, let's see, east, 13.08 degrees, north, like that. Awesome. Okay. Okay. All right, let's try example 4. Example 4 says, given that the magnitude of u is equal to 6 and the magnitude of v is equal to 10, and the angle between vector u and vector v is 120, determine a unit vector that's in the same direction of x plus y. Okay, x plus y. I assume, you know what? I think this is a typo. They never introduced x and y. I think this is a typo. I believe they meant u plus v. So I'm just going to change that. They meant u plus v. My apologies. I'm pretty sure. Otherwise, this wouldn't really be a possible question to answer, unfortunately. Okay, so let's do it. Let's figure it out. Well, first of all, I'm going to draw my vectors. So here we have vector v, and then we have vector u. And let's see, vector u's magnitude is 6, and vector v's is 10. Actually, I should make this more accurate. Vector v's should be longer than, and it looked like it was shorter before, like that. Okay. All right. So let's finish off our parallelogram. And what we'd like to know, we would like to know the resultant vector, right? Or actually, we just like to know a unit vector that is in the same direction, okay? So let's do it. Let's do that. So here we have the vector, that. And the first thing we need to do to find the unit vector is we need to figure out, well, hey, what's the magnitude of the original, right? So let's do that. Let's say that a squared equals 6 squared plus 10 squared minus 2, 10, 6 cosine of 60 degrees, which is equal to 136 minus 60, which is, let's see, 76? I believe so, 76. So therefore, A is about 8.72, right? Okay, awesome. So there we go. So there we have it. There we have it. So that's going to be our unit vector that's going to be in the same direction would be 1 over 8.72 of this vector, right? So 1 over 8.72 of the vector u plus v. So there we go. Now we've determined that this is the unit vector that has that same direction, right? Because this vector, u plus v, it has magnitude of 8.72. So if we divide it by magnitude 8.72, those cancel out, and then we just have a unit vector, right? So that's how we can determine what the unit vector is with that same direction. Now, it didn't actually ask us to find the direction. If it did, we could figure it out, but they didn't actually ask for that. They just asked for name a vector that is the same direction of this vector, but is actually the unit vector, right? That doesn't have that magnitude. So we need to find the magnitude so that we can change the magnitude for whatever it is. It says here also to create a vector in the same direction that we can multiply it by what? We can multiply it by 1 over the magnitude of u plus v. So this is a general rule. That's not something we can just do in this case, but just in general, we can kind of expand what we did here and say, well, in general, in most cases, or not, sorry, not in most cases, just in general, in all cases, um, we can apply this. We can multiply our vector by this, right? We can multiply our vector by this in order to create a unit vector in the same direction. So whenever you're asked to do that, just remember this rule and apply this rule, and it's as simple as that. All right, well, that's going to be everything for today. We will see you next time. Bye, everyone.